we're going to start looking at what we call translations and reflections on our basic graphs. And remember our 7 basic graphs: absolute value of x, x squared, x cubed, square root of x, the cube root of x, and the unit circle, the square root of 1 minus x squared. So we all know what the graph of the absolute value of x looks like. Now, by translations, we mean moving it up or down, left or right. Translations in y means moving it along the y-axis, which means moving it up or down. So we're going to say, what if we elected to move our absolute value of graph, absolute value of x up 2 units? This is obviously what it would look like. But what would be the equation of that? Well, the new function would be the absolute value of x plus 2. And you can easily check for that, because if you want to find the y-intercept, you simply put in 0 for x, and that gives you y equals 2. Remember, f of x is nothing more than y. Okay, and likewise, if we wanted to find the x-intercept, which obviously it has none, we would simply set y, or f of x, equal to 0, which would result in giving us the absolute value of x is equal to -2, which we know couldn't equal. Okay, so we look at other translations. Now, moving that 3 units down, we would have our graph looking like this, and the name of that graph would be the absolute value of x minus 3. Again, if we wanted to check this for the y-intercept, setting x equals 0, we'd have our x-intercept, our y-intercept down here at -3. If we set y equal to 0, absolute value of x would equal 3, which means x would equal 3 or -3, which we saw in the picture. So in general, we say if we start off with a function y equals f of x, or just f of x, and we can alter it by adding some constant value to it, it will be effectively moving that graph up. It doesn't have to be just absolute value of x. It can be any graph, even more than just our basic 7 graphs. Okay, so that shifts the original function up a units. F of x minus a will pull it down, or shift it downward, or translate it down a units. Now we look at what we call the translations in x. We look at our basic graph of x cubed here, and we're going to say, okay, what if I wanted to move this graph 2 units to the right? So if I move the graph 2 units to the right, this, what we call our point of inflection, okay, the origin point would move right here to 2, 0, okay, as we show, okay? But what would be the equation of that, okay? So the equation of that is the f of x, or y equals x minus 2, the quantity cubed. Now, a couple things, okay? You might be saying, well, I moved it to the right 2. Why does it say minus 2? Well, look at it. If you put in the x value of 2, 2 minus 2 is 0, 0 cubed is 0. That coincides with that x-intercept point. Okay? All right. Or one. Okay. Now, if we were to say, well, what happens if I wanted to find out what is this y-intercept? Well, the y-intercept is when x equals 0. If x equals 0, I have -2 cubed, which is -8, which is where this would be going when it intercepts. Okay. So now let's look at moving it 2 units to the left, as is depicted here. All right, and the name of that is y is equal to x plus 2, the quantity cubed. Again, okay, if you were to ask what is the x-intercept, we would set y equal to 0. Setting y equals 0 would say x plus 2 cubed equals 0, which would say x plus 2 equals the cube root of 0, which is, of course, 0. And then x plus 2 equals 0, x equals -2. And again, If we were to put 0 in here, we would have y-intercept would be 2 cubed, which is 8, which is kind of where that is going, okay? So when we're doing translations in X, they might be contrary to what you might generally think, but here we go. This notation, replacing all x's with x plus a, will effectively move it a units to the left. And if we were to replace all x's with x minus a, then that would be moving it a units to the right. Okay, so this is our translations in X, which are accomplished by replacing x with x plus a to move it to the left, x minus a to move it to the right. Now we look at reflections. Okay, all right, so if I say to you, let's flip this across the x-axis, then it would look like it would open downward, it would be concave down, but we ask what would be its equation. Okay, well, its equation is going to be the opposite of x squared. Okay, the opposite of x squared. And let's look at taking the graph of the square root of x. Okay, and let's ask, what if I wanted to flip that across the y-axis? Then what would it look like? It would look like this, okay? And what would the equation of it be? It would be y equals the square root of the opposite of x. And of course, it's important that you read that as the opposite, not as the negative. And if you wanted to validate this, you say, well, what is the domain of that? If I was asking what is the domain of that, then I would say, well, the domain of that means that the square root has to be greater than 0. So that would mean that the opposite of x would have to be greater than 0, which if I divided both sides by the negative would say that x would have to be less than 0, which is what the graph depicts. Okay, so we're going to generalize that now. Okay, for any function starting out, if you want to flip that across the x-axis, then the function is simply multiplied by -1. So as we saw with x squared, and we wanted to flip it across the axis, then the function is, the new function y is equal to the opposite of x squared. Okay, and if you wanted to flip this function, any function across the y-axis, then all the x's are replaced with their opposites. Okay, which is as stated there. Okay, so the opposite of f of x is going to flip across the x-axis. Okay, f of the opposite of x is going to flip it across the y-axis. Again, go back and look at those that we looked at previously. Flipping that across the x-axis, okay, gives us this, whose name is y is equal to the negative x squared. Flipping a graph across the y-axis is going to be accomplished by replacing all x's with their opposites. Okay, all right, we're going to stop it there and come back for another video.